Alright, Systems 2.1 homework. So, let's take a look at these. So we're trying to decide if answers are solutions to our equations, okay? To two equations at a time. So, a few ways we can do this. First, it wants us to determine if they satisfy these equations. So what does that mean? That means that we plug in these points to the y and x values of each equation to see if it holds true. So remember, the first is always the x value, the second is always the y. So in my first equation, with part A, for y, I replace y, I substitute it with negative 2 equals 3. Then I substitute 0 in for x. And then I simplify. 3 times 0 is 0. 0 minus 2 is negative 2. Is negative 2 equal to negative 2? Yeah. So it checks off for our first equation. Now we do the second one, y equals x. Okay, so y is negative 2, x is 0. Is 0 equal to negative 2? No. So we know that A isn't the point that satisfies, that is true for both of these problems. Okay, so it doesn't work. So now we try the next one, 2 and 2. So try that in the second equation. Y is 2. So we write 2, x is 2, so we substitute in 2. 2 does equal 2. So that one checks off. Now we do the next one. So instead of y, I put in the 2. So 2 equals 3 times, instead of the x, I put in the other 2. 3 times 2 is 6. 6 minus 2 is 4. 4 is not equal to 2. So this one doesn't work. Okay? So we're looking to find the point that works in both equations. That's the whole point of this one. So let's try 1 and 1. So 1 for y, 1 for x. 3 times 1 is 3, minus 2 is 1. Does 1 equal 1? Yes. Y equals x. 1 for y, 1 for x. 1 does equal 1, so it works out for both. So that's our answer. So then what they want us to do is they want us to graph both these equations and notice those points. So the first equation, slope-intercept form, negative 2 for y-intercept, negative 2 here, slope 3, make it a fraction, 3 over 1, so I go up 3 to the right 1. And that's the pattern we keep taking, up 3 to the right 1. Or I can go backwards, down 3 to the left 1. There's my first graph. Okay, now my second one, y equals x. So there's no y-intercept, so it would be like 0. Okay, then the slope would be like 1 over 1. So I go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. We follow that line, or backwards, down and to the left. Okay, so even though I didn't draw my graphs my points very well. So where's the point 1, 1? Well, it's right here, right? Okay, notice that had I actually drawn a straight graph, there we go, that's where they intersect, right? Look at point 2, 2. It's right here. Pretty close to the dark blue graph. It's on the orange, which is what we said. It worked for this one, but not for this one. And then the 0, negative 2 was down right here. So the y-intercept, it's on the dark blue, not on the orange. That's why it worked for this one and not for the second one. Okay, so there we go with those ones, guys. So, looking at number 2, same idea. X value of 2, y value of 7. So, 7 equals 2 times 2 plus 3. Just took the x and the y, replaced them with the x and the y. 2 times 2 is 4, plus 3. Is that 7? Yes, it works. Let's try the other one. Y value of 7, x value of 2. 7 plus 5 is 7. It works. Okay. So now the question is, do we need to try any of our other answers? Well, technically no, but yes, you should. Okay, and x for negative 7. Does negative 7 plus 5 equal 11? Definitely not. So we know that one's not going to work. You only have to prove it wrong in one of them. So 0, 5. Y value of 5, x value of 0. Works in that one, but doesn't work in the first. 5 for y. 2 times 0 for x, 2 times 0 is 0, plus 3 is 3, 3 does not equal 5, so it doesn't work. So pretty easy to see that here our answer was 2, 7. So where do we notice that? Well, let's graph these. This one, positive 5 for our y-intercept, slope of 1 over 1 because we can always put 1 in front of an x. We can always put 1 under a number to make a fraction. So it goes up 1 to the right one, up 1 to the right one, or down to the left one. My dots aren't quite on spot, but they're close. So there's my graph. Okay. And notice that, and maybe I should have done it this way, 2, 7 was that point right there, right? I don't know why I made that point right there with my finger. Now negative 7, 11 would be right about there. And 0, 5 is that point right there. So notice with this equation y equals x plus 5, it crosses those 2 points. Those 2 points are solutions for it by itself. But what about the second equation? Y-intercept of 3, slope of 2x. So it's like 2 over 1. So up 2 to the right one. Up 2 to the right one. We see that right there. Now, this negative 7, 11 was not a solution for any of our problems. Okay? The only one that worked for both was 2, 7. And so that's our answer. That's what we're looking for when we graph 2 equations on the same line. Alright. Now, number 3. A theater wants to take in at least $2,000 for a certain matinee. Children's tickets cost $5 each, and adult tickets cost $10 each. The theater can seat up to 350 people. Write an inequality that shows how many people can fit in the theater, and another inequality that shows how much money they want to earn. So, even though they can fit 350 people, we know that they won't always, so that's why an inequality is more appropriate. So let's think. So how can we do this? Well, we've got children and adults, right? C for children, maybe. A for adults. Okay, the number of adults, number of children. So, I know that if I take the number of children and add to that the number of adults, I want that connected to 350, right? Well, which one's the maximum? Okay, 350 is the maximum, it's the biggest, so this left side isn't going to get bigger than 350, so how do we write that? Well, we have less than, greater than, less than or equal to, or greater than or equal to. Okay, remember, whichever side it's open to should be the bigger side. So we want 350 to be the biggest side, so we open like that. Can it also be equal to? Yeah. So we can do C plus A is less than or equal to 350. That would be how many people can fit. Now, what about the money? Well, we know we want $2,000, right? At least $2,000. Okay? So, thinking about this, each adult ticket is $10. So if I take the number of adults and times it by 10, that's going to tell me how much we totally got for the adult tickets. Same with the children's. If I take children's and times it by 5, that'll tell me how much, and then I want to add those two together, right? So let's rewrite it like this. 5 times C plus 10 times A. And we want 2,000 to be the least, so we want it to be the smaller number, so it's going to point to the other side. Is it alright if it's equal to? Yeah, at least usually means it's alright if it's equal to. So there we go. There's our 2 equations. And they're kind of in that standard form. And I shouldn't say equations, I should say inequalities. Alright, now on to some problems that are a lot similar, very similar to what we did in class. Okay, and so it wants us to use the same information from the task, determine 5 possible solutions to these other constraints for Carlos and Clarita, using different colors or different dotted lines. Graph all the possibilities on the graph provided. So, we want to know how many 5 possible solutions. So we don't want it to be too small. We don't want it to be too big, but though I guess you could say too small, right? We just can't be too big. So let's think of some ways that we can look at this. So cat pens will be 6 feet of space. Dog runs 24 feet. and we have 360 feet total. So I know that however many dogs I have and however many cats multiplied by how much space they take and added together can't be more than 360. Okay, so we've got 360, and we've got C for cats, so 6 times C plus 24 times D. We've got to make sure that this does not exceed 360. It could be less than, so technically I should probably, oh, wrong way, huh? I should probably make an inequality, but we're going to think more along the lines of an equation. Okay, so we want to find 5 instances of cats and dogs where this works. Okay, so a few ways we can do this. Okay, it's always a good idea to think about, what if I had no cats and just started with dogs? So I could think of C as 0, and I just have 24, because that would cancel. 6 times 0 is 0. 24D equals 360, and I could divide by 24, and I get D equals 15. Does that work? Hold on, let me grab my calculator. Yeah, it checks out. So there's one possibility. I could also think about, what if I had 0 cats? How many dogs could I get? Or 0 dogs. I'm saying things backwards, aren't I? So we can kind of take the same approach. You could just do a guess and check, guess and check, guess and check. That would work too. I'm trying to show you some better ways. So let's say 6 times C plus 24, but dogs is 0 now. So we get rid of that. We get 6 times C equals 360. Divide by 6. And we get C equals 60. So we could have 60 cats within that amount of space. So now, what about in between? Well, when I make tables, I like to make a pattern. So is there a way I can make this into a pattern? Okay, yeah. Well, what's half of 0 and 60? It would be 30. What's half of 30 and 0? 15. It's between 30 and 60, 45. So I could try those numbers, and using that same concept of where I plug in the 15 for the cats. How many cats? If I have how many cats, that would use up 90 amount of my space, right? I'd go 6 times 15 plus 24D equals 360, and then we just solve it. So this becomes 90 plus 24D equals 360. Subtract by 90, and we get 24D equals 270. Okay. Then we divide that by 24. Now here's a problem. I get 11.25. Can we have that? No. Owners will not be happy if we do that. So that way is not going to work, is it? That pattern isn't going to work that way. It was a worthy try. Okay, we could try 30 though. If I plugged in 30 instead. 30 times 6 is 180. 360 minus 180 would give us 180 divided by 24 gives us 7.5. So that one won't work. These guys are out. Okay. So let's try some different numbers. Let's try 10. So I'd plug 10 in. Okay. So we'd have 60. 6 times 10 is 60. Subtract 60 from 360. So we'd have 300. 300 divided by 24 gives us 12.5. No go. So we're just going to have to keep guessing here, right? So they're not all working out to make it so easy for us, are they? Alright, let's try. What should we try now? Maybe we should try with the dogs. Maybe that would be easier. Okay, let's try 10 dogs. So 24 times 10 would give us 240. 360 minus 240 gives us 120. Divide that by 6. We get 20. Alright, that works. 20 cats And what did we say, 10 dogs? Okay, what if we went 5 dogs? So do the same thing. 240 times 5 equals 120. 360 minus 120 is 240. Divided that by 6, and we get 40. Okay, that one works as well. Anything else that we could use? Okay, 15, 10, 5. We can't use 20. What if we just did 2 dogs? 24 times 2 is 48. 360 minus 48 is 312 divided by 6 is 52. That works. So what did I say? 2 and 52? Alright, so then we can graph those. Alright, so we had cats for our x-axis, our horizontal, dogs for our y. And we've got 0, 15. When 0 cats, we go up to 15. So right there, that's 15. We've also got 0 and 60. So I believe that's at the end. I think I went clear out to 60 on this. Maybe. Okay, 20 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 20 and 10. So 15, 1, 2, 3, 4, 5. Okay, we also went to 40, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 40. So 40 and 5. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's actually 50. So, oops. So, oh, dang it. My little icon that moves it to the next page is right there. So I'm going to move that cats. That's 50. So 60 would be out here at the end. So 60 is out there and 50 and 2. Okay? So we could make that a line, right? Because we got everything just right. Nothing below, nothing above, so we're not having to deal with that inequality aspect of it. Okay, so now what could our equation be? Okay, well we've got, well, we made that equation, right? So now let's do it 5 for feeding time. So feeding time, so you read through this and you realize that 12 minutes per day for cats, 10 minutes, or 20 minutes for dogs, and Carlos has 8 hours. Well, how many minutes is that? 8 times 60. What, 480? So we've got 480 minutes total that he can spend. Each cat is 12 minutes, plus each dog at 20 minutes. So we can come up with an equation like that, and now we figure out cats and dogs. So it's always a good idea to start with 0 for cats, 0 for dogs. So then we'd end up with, for cats, 12 times 0 is 0, so 20d equals 480. So we just divide by 20, and we get 24 dogs. Now flip it around. We got rid of the dogs because they're 0. So it would be 12c equals 480. So 480 divided by 12 gives us 40. All right. Now let's start picking some numbers. Let's say, what if we do 2 cats? Let's start small. So I'd go 12 times 2, right? Plus 20d equals 480. So that'd be 24, so we subtract 24 from both sides. Trying to write this a little quicker. So I'd go 480 minus 24. So that's 456 divided by 20 isn't going to give us an easy number, is it? So we've got to think through this one so we're not wasting too much time. So I wonder if it'd be easier to deal with dogs. Okay, let's think about this. maybe if we solve for dogs, that would be a lot easier to figure out, right? Can we do that? Yeah. I can subtract 12c. So I get 480 minus 12c equals 20d. Divide by 20 on everything. 480 divided by 20 gives us 24. Minus 12 divided by 20 would reduce down to, let's see, 3/5 times c would equal dog. So the way you want to think about this is that 5 right there. So if my cat is something like 5 or 10 or 20, it should work out. So if I plugged in 5, 3/5 times 5, those 5s would cancel. I'm left with 3, so it would be 24 minus 3, which 24 minus 3 is 21. So for 10, 3/5 times 10, well, 10 is like 2 times 5, so the 5s would cancel. 3 times 2 is 6, or 3 times 10 is 30, divided by 5 is 6. So 24 minus 6, 18. What about 20? 3/5 times 20. 3 times 20 is 60. 60 divided by 5 is 12. 24 minus 12 is 12. So there we go. So we can plot those. 0, 24, 5, 21, and 0 and 40. So 40 and 0, so 15. So that should be 30 right there. That would be 40. So 0 and 40 would be a point right there. Okay. Or 40 and 0. Oh crap, am I doing it backwards? I am. My bad. Mix it up. So 40 would be right here. Okay, so that's 40, 0. 0, 24 is where we'd want to go. So it'd be right about there. Okay, then 5 and 21. Should be right there. 10 and 18. 10, 18, we should be able to kind of see that line there as well. And 20 and 12. Should be right there. So there's that line, representing feeding time, whereas the blue was space. So one more. Okay. Pampering time. The twins plan to spend 60 minutes each day brushing and petting each cat, 20 minutes each day bathing or playing with each dog. Clarita can do it for 8 hours. So we already know 8 hours is 480 minutes, right? So 480 minutes is equal to, well, cats 16 for cats plus 20 for dogs again. Okay, so once again, with cats and dogs, we do the same thing and figure out, with 0 cats, it would be 480 divided by 20, which would be 24. So on this one, that's 0, 24 would be right there, same spot. Interesting. Now, well, because 20 was for dogs last time. 0 for dogs, we just have 480 divided by 16 would give us 30. So on this side would be 30. Now, do I really need to put a bunch of other points here? Not necessarily. I could draw my graph with those 2 points, but it asks us to figure the rest out. So we need to do that. So probably our best bet would be to kind of do what we did that last time to figure out some of these where we solved for dogs so we could easily do it. So with our equation, we change it by subtracting 16c from both sides. So I get 20d equals 480 minus 16c. Divide everything by 20. And 480 divided by 20 is 24. So we get 24 minus 16 over 20 would be 4/5 C. So once again, I want to times by things like 10, 20, 25, those easy numbers. So if I go 4/5 times 10, okay, 40 divided by 5 would be 8. 24 minus 8 is 16. So at 10, we go up to 16. At 20, 4/5 times 20, and I'm kind of trying to hurry through this quick. That would be 4 times 5. 5s would cancel. 4 times 4, 16. 24 minus 16 would be 8. So at 20 we go up to 8. And then at 25, 4/5 times 25. 4 times 5 is 100. 5 divided by 100 is 20. 24 minus 20 would give us 25. Give us 4. And there's our last one. So there's kind of looking at those other three constraints, and we could add to that if we really wanted to, that original constraint we did in class. Okay? Alright, the last one's just graphing these equations, deciding if the point 35 is a solution to the equation. So slope-intercept form, y-intercept at -1, start at -1, slope of 2, make it a fraction. It's positive, so I go up 2 to the right 1. Draw my line, then we plot the point 35. Does the line cross that point? Yes. Okay, what are other 2 points? Well, all these points I touched would be solutions, okay, to that equation. So 0, -1 would be a solution. 1, 1 would be a solution. 2, 3 would be a solution, and so on. Okay, and we could even plug that into our equation to see if it works. Alright, number 8. Positive 2 for our y-intercept, plus 2, slope of 1 over 3. It's positive, up 1 to the right, 1, 2, 3. Up 1 to the right, 1, 2, 3. Up 1 to the right, 1, 2, 3. Or left down and to the left 3. That works as well. So all those points there, you just pick one. Those are all solutions. So 0, 2 would be a solution, that one. 1, 2, 3, 1, 2, 3. 3, 3 would be a solution. Okay, is 3, 5? Well, over 3 up, 1, 2, 3, 4, 5 isn't. Not on the line. So no, it's not. But here are some others. Okay, we could even go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So 6, 4 would be another one. Alright, last 2. Okay, positive 5. 1, 2, 3, 4, 5. -3, put it over 1, so we go down 1, 2, 3 to the right 1, down 1, 2, 3 to the right 1, 1, 2, 3 to the right 1. Okay, so is our point 3, 5 an answer? Nope, not on our line, so the answer is no. What are some? Well, that first one, 0, positive 5. That second one, 1, 2. That third one, 2, -1. Okay, then 3, -4. Those points are all solutions to that line. Okay, now last one, positive 4. To start us, -3 over 5, down to the right, 5. Or I can go up 3 and to the left, 5. Okay, so these points would all be solutions, right? 1, 2, 3, 4, 5, so -5. 1, 2, 3, 4, 5, 6, 7. That's a solution. Our y-intercept, 0, 4 is a solution. Also, 1, 2, 3, 4, 5, 1. 5, 1 is a solution. Okay, is 3, 5 a solution? Nope, because our line does not cross it. So the answer would be no on that one. And there we go, guys. There's our whole homework.